Hello everyone, I'm Divya Kabade from Kelly Institute of Technology, Hubli. I'm currently an intern at Ematex Information Technology. We are a group of three members, Abhishek K, myself, and Divya Revankar. We are doing this internship based on embedded system. During this internship, we have worked on the project wherein our topic was microwave oven simulation. The topics which we have learned during our internship period are Embedded C, Introduction to Embedded System and Microcontrollers, MPLAB X IDE, XC8, PIXM Lab, Introduction to various peripherals of PIC16 F877M microcontroller, interfacing various peripherals of PIC16 F877M microcontroller. We have given multiple quizzes and attended Disha workshop, which has ultimately helped us in the completion of our project. Before hopping to embedded C, I will give a brief introduction about C language. C is a versatile and influential procedural programming language. It is renowned for its simplicity, which makes it a relatively easy to learn. It excels in system-level programming, embedded system, and operating system development. Some important topics of C language are conditional statements, loop statements, operators, arrays, pointers, functions, strings, etc. Conditional statements. These allow you to execute different block of codes based on whether a specified condition is true or false. There are primarily two types of conditional statements in C: if statements and switch statements. If statements. These are used to execute a block of code only if a specified condition is true, and we can use an else clause to provide code that will execute if the condition is false. Switch statements. The conditional, this conditional statement is used to select one of many code blocks to be executed. It is often used when you have multiple conditions to check against a single variable. Now comes the loops. These are used to repeatedly execute a block of code as long as certain condition is met. There are three primary types of loops in C language: for loop, while loop, do while loop. For loop. This loop is often used when you know the number of iterations you need in advance. It has three parts: initialization, condition, and increment or decrement part. Initialization is where you set the loop control variable. Condition is the part where you determine the loop should stop. And increment or decrement is how the loop control variable is updated in each iteration. While loop. This loop is used when you want to repeat a block of code as long as the condition is true. Do while loop. This is similar to the while loop, but it guarantees that the code block will be executed at least once as the condition is checked after the block statement is executed. Now let's see operators. Operators are symbols used to perform various operations on data. Operators can be categorized into several types based on their functionalities. Arithmetic operators. These operators perform basic mathematical operations such as addition, subtraction, multiplication, division, modulus. Relational operators. These are operators used to compare values such as equal to, not equal to, less than, greater than, less than or equal to, greater than or equal to. Logical operators. These operators are used to perform logical operations such as logical and, logical or, and logical not. Assignment operators. These are used to assign the values to the variables such as assign, add and assign, subtract and assign, and many more. Increment or decrement operators. These are used to increment the value or decrement the value of a particular variable. Bitwise operators. These operators perform operational at the bit level, such as bitwise and, bitwise or, bitwise XOR, bitwise not, left shift, right shift, etc. Now let's see arrays and pointers. Arrays and pointers are closely related concepts that are fundamental to work with the data efficiently. Arrays. An array is a collection of elements of the same data type stored in a contiguous memory location. Elements in array can be accessed using an index starting from 0 for the first element. Arrays are declared with a fixed size during their creation, and this size cannot be changed during their runtime. Pointers. A pointer is a variable that stores the memory address of other variable. Pointers are declared by specifying the data type they point to, followed by an asterisk. Pointers are used for dynamic memory allocation and accessing elements of arrays and structures efficiently. As we have come to know few topics from the C language, let's see what is an embedded C now. Embedded C is an extension of C language and it is used to develop microcontroller based applications. The extension in the embedded C language from normal C programming language are the input-output hardware addressing, fixed point arithmetic operations, accessing address space, etc. Here arises the question, what is an embedded system? So, an embedded system is a microprocessor based computer hardware system with software that is designed to perform a dedicated function, either as an independent system or as a part of a large system. Some of the examples of embedded system are fitness trackers, medical devices, automotive systems, home appliances, ATMs, etc. The further slides will be explained by friend. Thank you.
Hello everyone, my name is Abhishek Kangar. Now I will further continue with the presentation of our project. Previously, we saw that what is embedded systems and what are the uses of embedded systems in our day-to-day life. We also saw that what are the importance of embedded C in the designing of microcontroller-based applications. Now further, we will look into the microcontroller. Firstly, what is microcontroller? We know that microcontroller is an integrated circuit which is capable of being programmed to perform a specified task. A microcontroller is a compact circuit that contains a processor, memory, and input-output peripherals. It is designed to execute specific tasks or control various hardware components in devices such as appliances, automotive systems, and electronics. Microcontrollers are commonly used in embedded systems to perform dedicated functions, making them essential for automation and control applications. They are typically programmed to carry out specified tasks, making them highly versatile in a wide range of applications. Now, let us look into some of the applications in which the microcontroller is used. Microcontrollers have a vast range of applications across different industries thanks to their versatility and ability to control various hardware components. Some common applications of microcontroller are in home appliances like devices such as washing machines, microwave ovens, and thermostats, and many more home appliances. Some of the automotive systems in which the microcontroller is used are airbag system, automatic braking system, engine management, entertainment system, and many more systems. Some of the consumer electronics also consist of a microcontroller, such as remote controls, smartphones, and smart TVs. The industrial applications of the microcontroller are as follows: robotics and machinery for a process of automation and monitoring, not only in the hardware field. In the medical field also, the microcontroller plays an important role. In the medical field, we can see the equipments such as insulin pumps, heart rate monitors, and infusion pumps in which the microcontroller is a very important part. Some of the other fields in which the microcontroller is used are aerospace and defense sector. They are used in avionics systems, navigation, equipments, and military applications. Not only in this, the in environmental monitoring also, the microcontroller is also used in the systems such as weather stations, pollution monitoring systems, and many more systems which will be helpful in the environmental monitoring. These were some of the applications of the microcontroller which is widely used in our day-to-day life. Now, let us look into the difference between the microcontroller and microprocessor. We know that microcontroller and microprocessor both play an important part in designing the electronics components. But there are some of the difference between microcontroller and microprocessor from which we can classify the microcontrollers and microprocessor. Some of the major differences of microcontroller and microprocessor are as follows. Microcontrollers can be understood as the heart of an embedded system, whereas microprocessor can be understood as the heart of computer system. Microcontroller is a controlling device wherein the memory and input-output component are present internally. A microprocessor is a processor where the memory and input-output components are connected externally. Microcontrollers are present on the chip memory, because of which the circuit is less complex, whereas the circuit is complex due to the external connections in microprocessor. The memory and input-output components are available in microcontroller, whereas the memory and input-output components are to be connected externally in case of microprocessor. Microcontrollers can be used with compact systems, whereas microprocessor can't be used in compact systems. Microcontrollers are and more efficient than microprocessors. Microcontrollers have more number of registers when compared to the microprocessors. Microcontrollers are generally used in microovens, washing machines, and air conditioners, etc. Whereas microprocessors are generally used in personal computers. These were the some of the major differences between microcontroller and microprocessor, because of which the microprocessor and microcontroller are differentiated among them. Now, let us look into the major part of our project, that is microwave oven. Firstly, let us understand what is microwave oven. We know that microwave oven is a kitchen equipment that uses microwave radiation to cook, heat, or defrost the food quickly and efficiently. It is common appliances for reheating leftovers, preparing ready-made meals, and cooking a variety of dishes. Microwave oven is used to heat the food using microwaves, which is of from the electromagnetic waves. In this project, we have used the four modes of the microwave ovens. We know that there are several modes of the microwave oven, but in this case, we have chosen the four modes. They are as follows: micro mode, grill mode, convection mode, and start mode. Now, let us quickly look into the these four modes briefly. Firstly, micro mode. In this mode, the microwave oven emits microwave radiation at a specific frequency, which is absorbed by the water, fats, and sugars present in the food. These microwaves excites water molecules, causing them to vibrate and generate heat. This heat cooks or heats the food quickly and evenly from inside out. Now let's just look into the second mode, that is grill mode. Many microwave ovens have a grill element typically located on the top of an oven. In grill mode, the microwave oven uses the grill element to produce radiant heat. This mode is used for browning and crisping the top of dishes. It works similarly to a traditional oven's broiler. Now let us look into the third mode, that is convection mode. Some microwave ovens offer convection cooking, which combines microwave cooking with the circulation of hot air. In convection mode, a fan distributes hot air evenly inside the oven cavity. This mode is suitable for baking, roasting, and cooking dishes that benefit from a crisp or brown exterior. Finally, Let us look into the start mode. The start mode is a basic setting to begin the cooking process. We select the cooking time and power level and then press the start button to initiate the chosen cooking mode, whether it's a microwave, grill, convection, or a combination of these modes. It's the mode that activates the cooking process according to our settings. Now, finally, let us look into the block diagram of the microwave oven. From this block diagram, we can see the basic working of the microwave oven. Here we can see that initially the microwave oven will be in the ideal condition. When we switch on the microwave oven, the display will be on the microwave oven along with the internal lights. When we place the bowl or the food inside the microwave oven and set the timer accordingly and close the door. After the timer is completed, our food will be ready to serve or ready will be ready. Further, Further, the microwave oven is turned off so that it can again go back to the ideal condition. This was the basic working of our microwave oven.
Hello everyone, my name is Divya Revankar. So let us now see the softwares that we have used. That is MPLAB XIDE, MPLAB X8 Compiler and PixMLab. These are the requirements. Along with the three softwares in PixMLab, we have used PIC16F, 877A microcontroller, 16 cross 4 CLCD, a matrix keypad, buzzer, fan and timer 2. So this is the architecture of PixMLab. It is PIC16F 877A microcontroller. We have RS-232, LEDs, buzzer, digital keypad, SSDs, matrix keypad, temperature sensor, I2C, GPIOs. So this is how our PixM Labs looks like. So this IC, that is PIC16F877A, it is a 40-pin IC and the size of microcontroller is equal to size of data bus, that is 8 bits, and it has 5 ports which are bidirectional: port A, port B, port C, port D, port E. Port A is of 6 bits, port B 8 bits, port C 8 bits, port D 8 bits, port E 3 bits. And these LED1 and LED this array, both the LED arrays, one is connected to port B and one is connected to port D. In port B, the LED arrays are connected from RB0 to RB7, and in port D, they are connected from RD0 to RD7. So let us just look at one of the port. So port B is nothing but it is an LED which is 8-bit wide. The corresponding data direction register, it is nothing but TRIS-B. If TRIS-B is equal to 1, it will make the corresponding port B pin as input. If TRIS-B is equal to 0, it makes the corresponding port B as output. So this was about our LEDs. And the same thing happens for port D also. The next thing is we have used the matrix keypad. That is 4 cross 4 matrix keypad. Keypads are widely used input devices being used in various electronics and embedded projects. They are used to take inputs in the form of numbers and alphabets and feed the same into the further processing. So this is our matrix keypad in PIC16F 877A. Next, this one. This is nothing but it is CLCD, character liquid crystal display, where we get the display here on the screen. Here, these are most commonly used to display the ASCII characters. And in the screen, some customization is possible. There are two communication modes, that is 8-bit mode and 4-bit mode. Next, we have timers. Timers are one of the most important workhorses for an embedded programmer. Every application that we design will somehow involve a timing application like turning on or off. So in PIC 16F 877A, it has three timer modules, that is timer 0, timer 1, timer 2. Timer 0 and timer 2 are 8-bit timers and timer 1 is 16-bit timers. In our program we have used timer 2. Next is a buzzer. This is buzzer. This. So buzzer, it is an electrical device which is similar to bell that makes a buzzing noise and is used for signaling. So to check the output of our microwave oven, so let us first load our hex file. So we get it as powering on microwave oven. So then after that we enter into menu display screen. We have four menus, that is micro mode, grill mode, convection mode, start mode. So if you want to go to micro mode, we have to press key number 1. It shows power as 900 watt and it enters into set time screen where we have to set the time in minutes and seconds. And if you press star, it gets cleared, and if you press hash, it enter. So I'll just write the time as 10 seconds. And if I don't want it, I can just press this star key, it will get cleared. So I'll just give 10 seconds and enter. So now the time has started. If I want to increment, I have to press key number 4. So the time will get incremented by 30 seconds. If you want to pause, we can press key number 5. And to again resume back, we press key number 4. If you want to stop it, we can press key number 6. And when we press key number 6, again it goes back to menu display screen, where we get the 4 different menus again. So this beep sound indicates that the time is up. Next, if you want to go to grill mode, you have to press key number 2. Even this is same as that of the first one, that is micro mode. Here also again I can enter the time. I'll just enter it as 5 seconds and I give enter. So at the end of 5 seconds we get a beep sound. So in order to go to convection mode, we press key number 3. Here we can set the temperature as 180 degrees Celsius. So the preheating time is 3 minutes. So after the preheating time, again we go back to set time screen. Here again we can set the time. As I set it as 5 seconds and I give it as enter. So again after 5 seconds the time is up and the buzzer goes on. So now next one is the start menu. For this we have to press key number 4. This by default has its time as 30 seconds. Now we have seen the output of the code. So this project on microwave oven using embedded systems successfully demonstrates the integration of advanced technology for efficient and precise cooking. By incorporating embedded systems, the microwave oven achieves improved control, automation, and user experience. This project showcases the potential of embedded systems in enhancing kitchen appliances, paving the way for smarter and more convenient cooking solutions. In conclusion, I would like to express my heartfelt gratitude to MRC team for their gratitude and support throughout this project. Their expertise and encouragement have been invaluable, and I am truly thankful for the knowledge and skills I have gained under their mentorship. Thank you.